Welcome to The Explainer. I am absolutely thrilled to have you here today because we're about to take a seriously fascinating journey. We are going to trace the exact path of modern web development, starting from just a single isolated keystroke on a developer's local machine and watching it expand all the way out to a globally distributed network serving millions. Whether you're building a simple informational static website or a highly dynamic interactive web app, the underlying pipeline is just an absolute marvel of modern engineering. It's a question we almost never stop to ask anymore, right? Like, how exactly does local code reach the world? When you hit enter on your browser in 2026, a web page pops up so instantaneously that it kind of just feels like magic. But behind that split-second load time is a massive, meticulously engineered pipeline. So today, we're going to solve the mystery of that pipeline, unpacking the professional tools and infrastructure that make the modern web possible. Okay, let's dive into this. Here's our roadmap for The Explainer, moving from the micro level of local editors to the macro level of global edge networks. First, the modern code workspace. Second, structuring HTML and CSS. Third, version control and Git. Fourth, modern deployment platforms. And finally, DNS and global delivery.
Section 1, the modern code workspace.
The professional workspace has completely evolved. On the left, we've got the reigning heavyweight champion, Visual Studio Code. It's an incredibly powerful, feature-rich IDE backed by a massive ecosystem of over 40,000 extensions. It can do almost anything. But because it's built on Electron, which is essentially running a hidden web browser in the background, it can be pretty heavy on memory usage. On the right, we have the new paradigm, AI-first editors like Cursor. Cursor is actually built right on top of VS Code, meaning all your extensions still work, but it integrates these wild agent-based workflows. It literally thinks alongside you, executing multi-file AI refactoring and running autonomous bug fixes. It's a fundamental shift from plain text editing to an intelligent coding environment.
Now, if you're someone who prioritizes pure speed above all else, there's Zed. Zed is the absolute speed demon alternative of 2026. Because it's built natively in Rust and uses GPU-accelerated rendering, it is virtually instantaneous. It's kind of like the difference between driving a reliable family minivan and a stripped-down Formula One car. It has a minimal memory footprint compared to those Electron-based editors, and it even features built-in real-time collaborative editing, making it smooth enough for remote pair programming. The tooling you choose really sets the pace for your entire project.
Section 2, structuring HTML and CSS.
All right, here's a rapid-fire list of engineering best practices for the actual architecture of your code. You want to write clean, semantic HTML tags, minimize your payload sizes, and utilize highly structured CSS layouts to ensure true mobile-first responsiveness. When it comes to media, optimizing large images into WebP or AVI formats and throwing in that lazy loading attribute prevents those super annoying rendering delays. Finally, you should regularly run Lighthouse accessibility audits. Why this matters is because the cleanliness of this local code directly dictates how fast, accessible, and search engine friendly the final deployed site is going to be. Bad code locally doesn't just mean a slow site globally, it means penalized search rankings and completely frustrated mobile users.
Section 3, version control and Git.
This brings us to how we actually transport our perfectly structured local code up into the cloud, the continuous deployment or CD pipeline. The sheer speed and automation of modern CI/CD is breathtaking. In the past, developers had to manually drag files to a server via FTP, but today it's completely automated. First, you write your code locally. Second, you push that code to a remote repository like GitHub using simple terminal commands, specifically git add, git commit, and git push. And third, the moment that code hits the repository, your hosting platform detects the change and automatically triggers a new deployment. You don't have to manually upload a single file.
So the crucial point is this. Continuous deployment means that your website automatically updates whenever you push new code to your repository. This is the absolute backbone of modern web development. It allows dev teams to ship updates, fix bugs, and launch features seamlessly, sometimes dozens of times a single day, without ever taking the site offline.
Section 4, modern deployment platforms.
Let's zoom out into the cloud infrastructure and look at the heavy lifters that actually host our files. We have three major players. Vercel completely dominates for highly dynamic, interactive web apps built on front-end frameworks like Next.js, offering instant preview deployments for every single code push. Then there's Netlify, which pioneered the modern static category, perfect for fast, pre-built websites, offering native form handling and automated integrations that make deployment incredibly easy. And then we have Cloudflare Pages, which is built on the world's largest CDN,
Cloudflare absorbs massive traffic spikes with total ease, offering unlimited bandwidth and edge worker integration. Depending on what exactly you're building, one of these platforms is going to be your perfect match. But hey, what if you want to skip Git entirely? Well, both platforms offer a really fascinating drag-and-drop feature right in the browser. Vercel Drop lets you drag a folder of source code, and it'll actually detect your framework, like Next.js, and run the entire build process for you automatically. Netlify Drop, on the other hand, operates without a build pipeline. It requires you to drop a completely pre-built static folder that already contains an index.html file at the root. It's incredibly liberating for developers who just want to bypass the terminal and get to prototyping instantly.
Now, what's this all going to cost you? Well, 100 gigabytes is the magic number here. That is the incredibly generous monthly bandwidth soft cap offered by the free tiers of GitHub Pages, Netlify, and Vercel. To put that into perspective, 100 gigabytes of text and basic images is enough to handle tens of thousands of visitors every single month, completely for free. Cloudflare Pages goes even further with uncapped bandwidth on their free tier. The days of needing a massive financial investment just to publish a scalable website, yeah, those are officially over.
Section 5. DNS and Global Delivery. To understand how we route humanity to our newly hosted servers, we need to break down DNS. The domain name system is basically the internet's ultimate phone book. When you type a human-readable URL like mywebsite.com, DNS kicks in to translate that alphanumeric name into the machine-readable IP address where your server actually lives. Without DNS, individual data packets, those tiny envelopes of code carrying your website across the network, wouldn't have the GPS coordinates they need to navigate the internet.
And this brilliantly illustrates how we manage all that traffic using core DNS records, the internet's traffic cops. An A record is used to route your root apex domain, which is just your simple website name without the www, directly to your hosting provider's IP address. A CNAME record is used to map specific subdomains, like www or blog, through your provider's routing tables. Getting these configured correctly is what seamlessly links your custom domain name to your cloud-hosted code.
Once the traffic actually finds your domain, we rely on content delivery networks. As this quote highlights, by utilizing global CDNs, these providers cache static assets directly on edge servers located around the world, minimizing routing latency. And look, latency kills web traffic. We've all stared at a blank white screen waiting for a site to load, and usually we just give up and close the tab. Distributing our code to edge nodes located globally is the ultimate performance hack, ensuring a lightning-fast experience for everyone, no matter where they are. So we've traveled from the micro-level choice of an AI-assisted code editor, through the strict structuring of semantic HTML and CSS, up through the continuous deployment pipelines of Git, onto the edge networks of modern cloud platforms, and finally, through the global routing of DNS and data packets. The entire pipeline is right there at your fingertips, highly optimized and largely free. Your infrastructure is ready. The only question left is, what will you build? Thanks so much for joining me on this explainer, and I absolutely cannot wait to see what you create.